Hello everyone, my name is André Pietro and today we're going to talk about the unit tests for C Sharp, okay? Unit tests can be created to any language and platform. So for example, you can create a unit test for C Sharp, Java, Kotlin, or any other language that you like it. Unit tests are the first barrier for the quality of software. So for example, uh, in a in a quality layer, we can have in a quality layer set actually we can have unit tests, you can have manual tests, automation tests. So the unit test is the first layer of quality in this set of layers. Okay, so this is why it's so important to have unit tests. Okay, because this will guarantee you prevent errors from um, code structure, and you prevent you create you add some bugs on your code. So if you return unexpected result, for example, uh, the first thing that will got broken is the unit test. Okay, so this is why it's so important to have them. In this case, let's talk about the C# case. Okay, my name is André Pietro. I'm C# and mobile engineering. I have some certification of Microsoft Azure fundamentals. I also have some team Kanban practitioner experience, and also I have the Git repository where you can find the this class code files and also other things in the future because it's kind of new in this case. Okay, let's talk about the unit tests themselves. Okay, unit test is a code which can test another code. Okay, so basically, an unit test is a code, okay, that you create to test another code. So let's suppose you have a calculator software, so you can have multiple functions on it. So you can have, for example, sum, you can have multiply, and you can have subtract functions. So for each case, you can have one or more unit tests for it. Uh, and the idea of the unit test, as I said, is not to test the code, is not to test the result from your code, but the structure itself. Okay, you see this better on the hands-on. A well-done unit test will cover the code structure, not the code itself. So as I said, the idea of unit tests is to keep your code structure covered. Okay, so if you the idea of a well-done unit test is if you change something, if you alter the rule of your code, the idea of a well-done unit test is to got broken. So if it is well done, it will got broken. Okay. An application is much easier to test when you have solid principles applied. So why we should have solid principles applied? I have other presentation about solid principles, but I'm translating it to English. Okay. But why it's so important to have solid principles applied? Solid principles basically uh, are some principles that makes your code more, as the name says, solid. So you can have your code more decoupled, a code more with a better maintainability. So in this case, for unit tests, it's very important to you to have single responsibility principle applied because you have small pieces in this case of code that can be tested. So if you have small pieces of code, it's much easier to test. Okay, to do tests. Is also very important to test to have the interface segregation principle applied because for mock to do your mock is very important to have uh, the interface to create mock applied to your interface. Okay, and also the dependency version is also that also complement this one is also needed to create your unit test. So first of all, before apply any unit tests, it's very important to have solid principles applied to any code you want to test. Okay, otherwise it will be much harder to create the unit tests. Okay. Okay, so as I said before, the unit test basically is a code that tests another code. Okay, so in this case, you can see that we have basically a function that receives some data. In this case, is receives some form data from a customer, and basically we have here a customer factory, and this customer factory is returning for us a customer object, and this one will be recorded into a file. And you can see we have already here some solid principles applied. So the customer factory is only responsible to create this customer, and this on in this case is an interface I will show you later. So we have a Moq applied for this. We have a Moq applied also to file manager. So as you can see, we have the test case here. So in this case, we have a code created to test this code. Okay, so each case will be one test case will be needed. So once I recognize a case, a business case that I have, then I can create an unit test for it. So let's suppose if we have two cases here. So for example, an if and else. So we could have two cases, one for if, other for else. Okay, but basically this is a basic case. Basically we are creating some modules for the unit tests, and themselves basically are expecting to return a new customer in this case, and in the case of save data, basically is just expecting to be called. Okay, I'll be talking more about the unit test itself later. Okay, in the hands-on, but it basically is this: it's a test created to test another code. It's a code created to test another code. In this case, your software. So this code you test your software. It's necessary to look over how many cases you can find in a function. So as I said before, you need to have this kind of vision. Okay, so you need to verify how many cases you can find. So as more as you have unit tests, is better for our code. So in this case, we can identify one, but in other cases, you can identify more cases. Okay, so as I said, in cases when you have decision structures like if else or switch cases is very uh, is very important to create more unit tests for this kind of cases. For each case, you have a unit test. For each case, you can have a unit test or more. So as I said, you can have one or more unit tests for each case. It's called unit test mainly because you have a small piece of code being tested, units. So as I said before, once you apply your solid principles, then you will have all your code split in small pieces. So it will be much easier to keep your code testable. Okay, because later you will see that you have like modules. So for each module you have an interface. So once you apply interface segregation, dependency inversion, and single responsibility principle mainly, it'll be very easy to test your code because you use these interfaces to do the modules. Okay, talking a little bit about the names. Okay, so unit tests should follow the same structure as the related project that's being tested as a good practice. Okay, so basically, as you can see in this project here, we have a print service inside the folder of service, and we have a unit test project here that's following the same structure. So you have a print service unit test here, okay, and also we have other structure outside the folder. So if you look here to the Form 1 also has some unit tests for it, and it's following the same structure as the related project that's being tested. Okay, so in this case we have workshop 1, and they have workshop1.unity.tests for the unit tests. Okay, so it's a good practice to keep the same structure, so it'll be easier to find the unit test when you search for it. Okay, let's go into a little bit more about the unit test itself. So when you talk about the unit test, okay, so it's a good practice to make the unit test more readable. We create on this pattern here, AAA pattern. So we have a hand, act, and assert. On a hand part, we are responsible just to set what we need. Okay, so in this case, we are expecting that this when show data, when show successful, should print pop-up. Okay, so basically, as once you have Windows Forms, it's harder to test few things. But in this case, we receive a print pop-up. We do a mock for the uh, for the file manager, a mock for the print itself. Okay, so this print basically is responsible to return a string. So we are basically expecting for a string, and also we have a print pop-up factory mock. So this print pop-up factory mock uh, is also mocked because we have solid principles applied before everything. Okay. So in a hand, as the name says, we are handing everything we need. We are mocking everything we need. In the act, we basically call show data function. So in this case, the customer facade is responsible to receive all the data to execute the function itself. So in this case, we have all the molecules inside this object that is a real object, and this real object have all these mocks inside of it. I will show you how in the next steps. Okay, but basically, once you have all these references being used inside of this object, we can call the real function here. Okay, I will show more details about these next steps. Okay, and after the execution of the function itself, we can assert if what you expected happened. Okay, so in this case, we are asserting if the print pop-up factor mock created the function once. So we are expecting that the function we are expecting to the function be called once in this case. If you are expecting to be called more than once, then we have other functions to verify these too. In this case, we are using Fluent assertions. Okay, so I'll talk a little bit more about Fluent assertions in next slides, but in this case we are using Fluent assertions. For Moq we are using Moq library. Okay, and for the test itself you are using NUnit. Okay, as I said in the previous slide, we are using NUnit, Moq, and Fluent assertions. So these are libraries that you can find in our public NuGet library. Okay, so you'll be able to be using them. They are very efficient on this work to do the unit test for Sharp. So you can do strong testable applications with them. Okay, code coverage. Code coverage is a metric used to know how much of the code is being tested. Okay, high coverage does not essentially it's kind of missing here, but it does not essentially means high quality. It's part of it. So a high coverage uh, help means basically that your code uh, has a high has most of the part tested. So this is good, okay, but uh, it's also need your code does not really needs just high coverage, but also well done unit test. Okay, as I said, your unit test should test the code structure and not the value that's returned itself. Okay, let's talk a little bit more about the dependency injection before we go forward. Okay, so I created an application here that I will show you soon, a small application that's a form, basically, a customer register. So in this customer register, we have some dependencies. Okay, so uh, as I said before, I applied the solid principles. So we have all the interfaces segregated by responsibility. We can also you can see that you can have a class for customer facade, a class for customer factory, and for all the other responsibilities here. Um, so basically, when what is a dependency injection? Okay, so dependency injection means that uh, you your class basically doesn't really need to know what are the concrete classes that it will need on the runtime. Okay, so on the development time, you be able to map what will be your concrete classes, and these classes will just and this instance of classes will be just injected on runtime. Okay, this makes your code much more decoupled, make your code more maintainable too. Okay, and also much more testable, as I said. So this also makes part of the principle from dependency inversion. Okay, that the high models should not depend on the low models. Okay, if this happens, so we have a dependency inversion case. So this is not good. Okay. The idea is to the high models and the low models, they both should depend on interface. Why should we always develop software thinking about interface? Because once you think about interface, you are not coupled to a rule. Okay, so once you are developing to interfaces, you are coupled to the contract itself. So once you are once you are thinking about interfaces, you just need to know what you need to pass to the function and what you are expecting. You don't need to care about what the rule is inside the function. Okay, so dependency injection, as I said before, you keep your code decoupled. If someone change the rule and the filter on the concrete class, you don't need to care about it because you are just expecting the interface. So we don't need to care if someone changes the rule. Okay, so we have a lot of advantages dependency injection. Talking a little bit more about the dependency injections themselves. Okay, so basically, in compile time, we have a class that has some reference to interfaces, as we said before. So when we are compiling, we are developing, so we are thinking about interfaces. So we are, for example, let's suppose we have a class A that it needs an interface B and an interface C, and when we have a runtime, we have the dependency injection on them. What does this mean? This means that we have the concrete classes injected on each of them. So when we are running the program, we can have some mechanism to do the injection. Uh, so in this case, when we are running, we have an injection of the class B on interface B. So class will be able to read all the functions of this concrete class, and the same for the C. So when we run the programming, interface C will have the behavior of the concrete class C. Okay. Uh, we have some tools to do this work for us currently on C Sharp. For example, we have like Automapper, we have Maphy library from Microsoft. But for this project, I used Ninject, okay, just simple library just to do the example. So the Ninject is doing all the work for the dependency injection in this case. You can also, in some cases, depending on the design pattern you are applying, different implementations for the same interface, okay? But this is other topic. In this case, we have just one implementation for an interface, one implementation for an interface. Okay, and when we are doing the unit tests, basically we create what we do is to create a new Moq, a fake class, a fake implementation for the interface. Okay, basically this is why it's so much easier to test uh, an class within that references interfaces, because we can change the behavior of the implementation. Okay, so let's talk about the Moq itself. Okay, so basically Moq is a library that help us to make the concrete classes for the tests. Okay, so with this library, it's much easier to do this. Okay, so the Moq itself has some functions that can help us to do the mock. Okay, so we have the setup that configures the mock. So with the setup function, you can configure the mock as you want. We have the callback function. Sometimes you need these asynchronous functions, execute something after the call of a function. We have throws an exception when method is invoked. In this case, this is very useful to test the try-catch batch of code. We have also the verify, that it verifies the execution of the mock. Very useful to validate methods that return void, so you can verify if it was called at least. Okay. Mock behavior. Okay, let's talk a little bit about mock behavior. You have two kinds of the mock behaviors. Okay, so we have lose. When there's no setup, it returns the full value. So for example, if you have, let's suppose you have a function that you have two callings to another, to a mock, for example. If you does not do the setup, so in the case of lose, it will create automatically setup for you. In this case, so for example, if you alter this function and add another call to another function of that mock, so lose behavior will keep the unit test running. So this is not very good. So it's recommended to use strict. So strict will ensure that you have all set up for all the calls of the mock. So let's suppose, for example, you have 3 setups. So you have, for example, for three calls for that mock. So you need to do setup for each of them. And if you add another call in that function in the filter, your unit test will got broken. So this is good. So always when possible use strict, but it's not bad to use lose. Okay, but it's recommended to use strict. Sometimes it's not possible to use strict. You see that sometimes, for example, you need to return a value before the end of the function, for example. So in these cases, we need to use lose. Okay, but this also means you have some problems of solid principles too. Okay, so let's talk about a little bit the application that I created here. It's just a simple application in Windows Forms with some fields. So in this case, is a customer register. that you can add some names here. Andre 31, um, Green Street, for example. Put number here. Okay, we can put last name here. 2. Okay, ID number 123. I can save these and show in another form, so you have just two registers, okay, because I created the other one before. I have test the register and then the register that I just created here. And basically, let me show you how did we create uh, this program here. Okay, so we have the print pop-up that is just responsible to show the customers themselves, and they have the main form, that is this one. So you have the save customer and the show customers buttons. Uh, save customer For save customer we have the button one click. It's not good name, but no problem in this case. Uh, we in this case just uh, send out the fields and record them on the file. I have also the show customers function. And you can see all of these functions are referencing to interfaces. So as I said before, the dependency inversion principle is being obeyed here because we are following all the interfaces and we're not referencing to concrete classes themselves. So this is very good for the unit test because we can inject the mocks that we need on them. Okay, so let's take a look at this customer facade interface. If I go to Control F12 in Visual Studio, I can go to the implementation itself. So let's take a look at what does we have here. So basically we have the save data and show data functions that we are using on the form itself. So for save data we have the customer factory and have the file manager, and for show data we are using the print. That's a print service basically. We are using the print pop-up factory, and they're using the file manager too. Okay, so you can see also in customer facade that we are following the dependency version principle, also with the single responsibility principle and the interface segregation principle for sure. Okay, so this will make us able to create all the unit tests. Okay, I created already an unit test in advance here uh, to not waste too much time um, with this. So let's take a look at the packages that we have for NuGet. Okay, so for the unit test application, for the unit test project, better we have the FluentAssertions library. You have the Moq library. We have also the NUnit library. So these three libraries will be needed to create the unit tests themselves. Okay, so the first class we can create, as we saw in the presentation for PowerPoint, we need to follow the structure from the code. So we can take a look at this customer facade and test this first. So we can do like add a new class. Okay, and you can add customer facade unit tests. Okay, basically, and you can do like public key, and this will have a property called test fixture. Okay, so this will say basically that this is a test class. Okay, and also you need a setup. So we have a public void setup. This is a void function that is responsible to arrange all the necessary dependencies that we need to or unit tests, all the unit tests. So in this case we call it setup. Okay, so basically let's think about first the load function. That's kind kind of easier. Okay, so let's take a look at the customer facade class. So in show data, we need a file manager mock. Okay, we need a print. There's the print services. So this name is not very good. Let me just fix this here. Print service. Okay, let's apply the rename here. Okay, so we need the print service, we need the file manager, we need the print pop-up factory mock. So we need 3 mocks for this function show data. Okay, so once they are all on interfaces, will be very easy to do. Okay, so let's do the first. The first is the print service. Okay, so we can do like public mock I print service print mock service mock. Okay, get and set. And also let's see the other ones. So we have file manager, so we can have like property mock I file manager. And also we can have the print pop-up factory. So we need all these 3 mocks, so we can create like public mock print pop-up factory, I print pop-up factory, and the print pop-up factory here, and can do like get and set here that we are obligated to use. Okay, on setup, we need to do the first arrangements for the unit tests themselves. So we can do like print service mock receive new. So we do the injections by hand here directly, because this is an unit test code. So there's no problem to use new statement on unit test code. Okay, because the test code. So we can do also let me adjust this here. So file manager is a file manager mock 2 that you need to do the injection here. So you can do like new file manager and also we need to do like here print pop-up factory that we receive a new print mock of print pop-up factory. Okay, we also need a real instance of the class that we are testing. So in this case, we need an instance of customer facade. So you can do like customer facade get and set. Okay, and right here we can do the injection. So customer facade, it's a new customer facade. So customer factory CB customer factory mock factory, but this one we don't have yet, so I'll keep this for the next test. We have file manager that we receive new file manager. Oh, sorry, we receive mock file manager mock dot object. So we have the mock being injected here by reference. We'll need also the print pop-up factory mock. This name is wrong, so I need to change it right here. Mock object. So once we do this, we have all the reference being applied to our real object, that's the customer facade that's being tested. And we also have so we have already the file manager, we have the print the print pop-up factory, and you have the print service. So I need to do the print service, and have the print service mock that object. Okay. Okay, so you already have all the things that we need for this test. Okay, these ones need to just fix here. Okay, so we are basically instantiating our mocks. Okay, and here we are just sending all the mocks for the instances that we have inside our true class that we are testing. So in this case, we are injecting a mock on this. In this case, we are injecting a mock on this interface, and in this case, we are injecting a mock on this. Okay, so now we can do a test for the show data. Okay, so let's take a look first. What does show data function does? Okay, so basically, the show data will print customer, call file manager that returns a list of customers. The print customers will return a string, and you have also here a return for this pop-up factory, so that will return a new print pop-up that's a form. Okay, so this print pop-up is the form that shows all the customers, and so basically we need a mock for this, a mock for this also. You also need a mock for this one too. Okay, so let's back to our unit test class, and here basically I will create my first unit test just then in this property here, and you can do like public void. Sorry, we are inside the function, so you need to delete this and go outside. So we can do like test public void on, for example, we can do on show data when show successful. What does it does is show print pop-up, but this is not testable because this is a form. Forms are not very good to test, so we can test, for example, if you created the pop-up. So print pop-up should be created. Okay, we can test something like this. Okay, for this we need basically a print pop-up, because in this case a print pop-up is native from .NET framework, so this is a form. Okay, so there's nothing to do. We need the instance. We need a file manager mock also. So you do the first setup. So as we said on the PowerPoint presentation, the setup will make us able to mock a behavior to the interface that we are injecting our mock. Okay, so in this case, what I want to do is to say that when I have the func.read, so when I have file manager mock.read, I want to return a new list of customer. Okay. So also this is why, because when we have the read here, so when we are reading here on the file manager, we are returning a list of customers. So I want to mock this behavior here. So you do this by we do this through setup. Okay. So other thing we need to mock is the print mock. Okay. So basically we have the print services. So I want to do the print mock for the customers. So we have the print service mock dot setup. Okay. And I can do like print customers and I say here that I will receive it any of list of customer. Okay, and this one will returns any string. Okay, can return string but empty, for example. We don't care about this for now. Okay, because the behavior of this specifically, we can do a specific unit test for this on the filter. So when we do the unit test for this class itself, we will test this behavior, but this is not the case, so we don't care basically what we is returning. Okay, print service setup. So we also need a print pop-up factory mock setup. So we do this setup, and you say that the function here that be called will be the create, and this one we will returns print pop-up. Okay, and the print pop basically is this. Oh, sorry, this is on is wrong. So print pop up. Okay. This all of things, this bench of things we call arrange, because this is everything we need to arrange before our unit test. This is the act. So in the act, basically what we need to do is to call the true function here, show data. And for the last, we do the assert. Okay. So for assert, you need to do print pop-up factory mock, sorry, and verify func.create times.once. Okay. Okay, our unit test is done. Basically, what we're doing here is set up in all the mocks we need. So we are mocking all the behaviors we need. So we are saying that this function will return this function will return this, and the print pop-up factory is return a true instance of it because it's a form. Okay, so there's no way to mock this, so we need to return a true instance. So we have a range done. Actually is the action to call the show data, and I also have the assert here. Okay, so basically what we need to do here too is to verify the calling of the factory. So this will verify if the function of the create of the factory will be called once. Okay, let's run the unit tests and see what happens. Okay, our unit test ran it well. Okay, we can talk also a little bit now about the mock behavior. Okay, so mock behavior, basically we can have loose and strict, as we said on the presentation. So the strict will obligate us to have all the setups set for the current mock. So if you put this as strict and run, it reruns actually because we have all the mocks for that. So let's try now. It's basically running. Let's wait a little bit. Okay, it ran it well too, but let's suppose, for example, if I do like remove this this setup read. Okay, so we can do like comment this and test again. Okay, you can see that this test got broken because you have no mock for this function. So let's take a look. You can see it got broken because it's basically saying we got mock behavior strict, and when we have mock behavior strict, it will obligate us to have uh, all the setup for all the mocks we have. So if I put this as loose, okay, uh, we also will need this for the print service too. Okay, so you can do loose for print service. You will see that it will allow us to let this as this, because in this case it will return like the full setup for this. If you don't have a setup in loose behavior, it will return the full value. Okay, but the full loose is not recommended most of times because, for example, if someone alter your code, add another new call, for example, a new call on the filter, strict behavior will obligate to keep it updated. Okay, so any change of the code, any call that you add, will broke the unit test. So this is good. This makes your code stronger. Sometimes it's not possible to keep it strict, okay, but when possible, you are recommended to use this. Okay, so you can remove this comment, and our unit test will run well again. Okay. So let's now the test is to run, and machine is kind of low. Okay, but it's fine. It passed. Okay. Let's take a look now at our save function. In this case, I want to show you some things we can do. Okay, so in this case, we need the customer factory. Okay, we also need the file manager. The customer factory we didn't create yet mock for this, but the file manager we already have. So let's create here a customer factory mock. Okay, so we have like a mock for customer factory. Okay, and we do all the same for this. Okay, so we can do like customer factory. This name is not very good, so you can do customer factory mock. Can do customer factory mock, and I receive a new customer factory here, and mock behaviors is strict. Okay. One thing is that we can create now our unit test for the save case. Okay, so in save case, basically we are receiving some information from the form that I showed you in the beginning, and we are creating a customer and saving on the file. So the first thing we need to do is to mock the factory itself. But first, let's create our unit test. I just forgot. So we can do like public void on save data. Okay, what will happen? So when have multiple customer must write data. Okay, so in this case, basically, I will show you a different thing. So we'll receive a customer by the call of the unit test. I will show you how we can do this. Okay. So at first, we need to mock the customer factory. Okay, so you do a setup for the customer factory here. I will do my hand here. Basically, I'm setting up the creation of the customer here, I can receive actually anything, so I'm not obligated to set out this information because this is not a specific test for the factory, is a test for the save function from the facade. So we can actually change this. Okay, we can do like it.isAny of string. Okay, so this way we are testing the structure and not just the value itself. So we have these two options in this case. Okay, let me just remove this. Okay, it's missing another one. Then we do like this. Okay, then you can return a new customer. You don't care about the value for now, okay, because this is not the unit test for the factor itself. So this is just a mock. So we just need to return something to test the structure of the code. And also we need to set up the file manager because we will write the file. So you need to set up and do the function and do func.write. What this will expect is some customer. So you can do like it.isAny customer. Okay, now we will just call our act here. That basically we will call our true function again. So you call the save data this time. I have already this code here. So you can do like this. So we receive a customer here on the signature of the function, and call our true function here. Once it has all the injection of our mocks here on the setup, we are fine because we have all the instances that we needed, and also we have our setups for the behaviors you want here. Also, we can do for last or assert here. And what we want to verify basically is that we can verify if it writes the file, and if we can also verify the creation of the customer. So you can have a customer factory mock dot verify, and you can have func.create, and you can copy the same from here because this is what you are expecting. So you are expecting this structure to be called. So we are verify this is called once. So you can go comma dot times dot once right here. And also you can verify file manager mock verify all. So this verify all will verify if all the void functions will have been called. So in this case we have this void function being called here. You can see that this is a void function, it just writes the file. So this will verify all the functions from these setups, and this will verify all for these setups. And you might be thinking, how do we inject this customer here? Okay, and this is saying that we have multiple customers. So we can do a different thing here. What we'll do here basically is to create a static function. Okay, I have the code here. Okay, I'll paste what basically I paste here is a test customer like list, but it is a yield return that we have the 3 customers here, and each one of them will be inserted in a unit test to relate the unit test to this function, this static function here. So each one of them will be tested. We can do like a test case source and give us the name of the function, that is name of, and give the name as test customers. Okay, so if you run this, Let's see what happens. So we got a problem. Let's take a look. Okay. Function.create is being expected to be called. Okay. So we had some problem on the call.create function. So what we do in this case, we need to debug. So we can also debug the unit test. So let's take a look. I just put a breakpoint here. It press F12, F11, sorry, F11, and see what's happening here. So customer factory is being called. Okay. It's saying me that the customer factory mock is not being called. Okay, so we have the customer factory, but we don't have this customer factory being injected inside our object here. This is why this is happening. So we can do like customer factory mock dot object. Okay, and then our test now probably will run. Okay, I'll just run the unit test. Let's see if we got success. Okay, seems now everything ran okay. Okay, we can also debug just to show you how the customers are being injected inside this. So we can see that once you have 3 customers here on this static function, we also have 3 test cases because each customer will be a test case. So we have the first customer, that is the lion, that's the first one. If I press F5 and go red, we have the Scar King, that's the second. The press F5, then you have the third one. That's the Sarabi Queen. So you have the 3 unit tests being fine. So we have 3 cases, each one for each unit test, for each customer. Okay, that's are some unit test cases that we can have. Okay, I can show you also an unit test for a factory, for example, just to show you more a few things. So for example, here you can see that we have a factory folder. So you can do like a new folder here and have factory. So we are following the same structure. So you can do like customer factory. So let's do like customer factory unit tests. Okay. So it's the same thing this time. I think it will be easier. Okay. So because we have just a small function, so we can do like test fixture here. We can have a setup. So public void setup and on the setup, what we'll do is to take a look at the customer factory, see what we need. Actually, not need any mock in this case. You just need to call a function, so it'll be much easier. Okay, we don't need any mock in this case. You just need to call the truth, the true class here and test it. Okay, so can have a customer factory for true in this case because this is what we are testing. It's complaining here because you don't have the reference. You just insert the reference here. And what we can do is to basically create a test here and do like public key void um, on create. When create, what we expect from a factory is to return new instance. Okay, so what we are expecting for the factory basically is that when we have, so we can do like an arrange, like arrange customer factory dots uh, uh, basically do we not need this, so we can do an action, so we can have a customer factory dot create, and this one is expecting a lot of strings, so we can have, for example, um, some a different thing we can do. So when we have more primitive types here, we can do like test case, okay, and you can pass some arguments. So you can pass, let's see what we need here. So we need address, age, 1 2 3 4 5 6 7 8. We need 8 parameters, so you have 1 2 3 4 5 6 7 8 parameters. Okay, just for some tests. Okay, I put some value here just to for tests. Okay, you can do like this, just for example. And right here we do the same, so you receive string, and you have the, you can copy the same structure from here, because it's basically the same. Okay. So here we expect a customer, and by here we will create this, but we remove all these things that we don't need here. Okay. On a search, what we can expect is the instance itself. So what you can do is customer we can try should be of type customer. Okay, because we are expecting a type customer. Basically it's this. We actually don't need setup in this case. Okay, we can do many cases of test here. You can use your creativity here, okay, for the test case. So let's run the test, see if you have some success to verify if you are returning the type you were expecting. Okay, we have some problem with new pointer. Okay, let's take a look. Basically, okay, we need just set up here because we need an instance. So once you need an instance for it, the instance will be used for all the unit tests. So you can do this as a setup for sure. So you can do like customer factory new customer factory, okay? And again, this will be our setup. Let's run again all the unit tests here. Okay, we are missing a pointer here. you can see this time we had success because we are receiving what we are expecting. So basically, this is much more simple than the other examples. So basically, what we are doing here is just entering the function and verifying if this one is returning what we are expecting based in this case that we have here. So in this first case, we can see that we have all the parameters we are passing by here. So each one is a test case. If I press F11 here, you can see it is just going through the function and creating all the properties. So I press F5 to go forward, I remove the breakpoints for F5 again, and see all the unit tests are fine. Okay, so all the unit tests are running well. One thing I can also show you is how is the coverage. So in this case, I'm using code coverage by ReSharper. Okay, so I will run the cover unit tests, and you can see the percentage of the unit tests that is being the percentage of the code that's being covered by unit tests. I have a small percentage here, but we can see by here that we have some functions that already are being covered. Okay, so in this case, it's covering this one. It's covering all these ones that are in green. So I'm covering these because it's calling by the unit tests. So let's take a look at the customer facade. Let's see unit test, customer facade, unit test is okay. Let me open here. So here we have the customer facade. So you can see that the customer facade that we created is 100% tested. So you can see that everything here actually is fine. So everything here is tested. Everything's okay. Okay, so we have 100% of this tested. Okay, so let's go again to the solution explorer. So let me do the cover unit tests again. Okay, so here we can see that we have all the customer facade tested, well tested. Okay. So we can see also specific functions if you want. So for example, if I do like, if I go here and do by here, I can see if is this function covering my what I'm expecting. So I can go here, cover range test, show data. Let me take a look again. Okay, so it's covering everything I need. For some reason, it's not showing the green line here. It should show like a green line like this here, but I can see by here that it's 100% covered by the unit test, so it's fine. Okay, okay, guys. This is a little bit about the unit test I want to show you. I want to show more videos in next steps about this. I have other cases that we can be using also in unit tests, for example, in a synchronous case and exceptions or other kind of things, and can follow in other videos. Okay, thank you for watching. Bye bye.